more of those examples before we move on to section 5 here. We're going to look at number 10 from the notes for section 4. We're going to do that one pretty quickly. And then we're going to do the rest of the notes from section 5. So number 10, very, very similar to what we just did for you guys as one of the homework problems. But let's take a look and remind ourselves how this works from last week. In order to get rid of these fractions, again, we talked about fraction busting or some similar terms. The goal is to just get rid of the fractions so we can solve this like normal. In order to do that, I need to know what the least common denominator is so I can cancel out all the fractions. So looking at this, I'm seeing this x squared minus 6x plus 8. More than likely that factors. I'm looking for two numbers that multiply to 8 and add to 6. Any ideas? You guys agree? Do 4 and 2 work there? See some head nods. 4 and 2, so x minus 4, x minus 2. And as luck would have it, we've got these two are the exact same two factors that we had before. So that is my least common denominator. It covers all of my denominators. So what I'm going to do is multiply by that. Multiply both sides of the equation by that least common denominator. So this side times x minus 4, x minus 2, and this side times x minus 4 times x minus 2. But what will happen then is that that gets distributed into both of these fractions. So when I do that, I'm going to rewrite it so that both of them are multiplied by that on the top. So this one, x minus 4, x minus 2, and this one times x minus 4, x minus 2. So really, all three of my fractions get multiplied by x minus 4 times x minus 2. And then if I go through, all of my denominators should reduce. So on the right-hand side, it's nice and easy. X minus 4 over x minus 4 is 1. X minus 2 over x minus 2 is 1. On the left-hand side, only some of it's going to reduce. I've got the x minus 4 and the x minus 4 reducing to 1. And the x minus 2 here, x minus 2 here reducing. What I'm left with is x times x minus 4 plus 1 times x minus 2 is equal to 2. Perfect. No more fractions. Do the distributive property. X times x is x squared. X times negative 4 is negative 4x. 1 times x is 1x. 1 times negative 1x. 1 times negative 2 is negative 2. I can combine like terms. Negative 4x plus 1x is negative 3x. X squared is still there. I have x's and x squareds, so I want to get them all on the same side. I'm going to subtract this 2. X squared minus 3x minus 4 equals 0. Are we okay so far? Again, multiplying by the least common denominator, canceling all the denominators out, doing any distributive property as we need to. Now, this should factor. What multiplies to negative 4 and adds to negative 3? A little louder. I'm hearing a couple different answers. Any ideas? And several people now. Do we agree 1 and 4? 1 and 4 should multiply to negative 4 and add up to 3. Where should I put the negative? On the 4. That way I get the negative 3 that I want. So my two answers then should be x is equal to negative 1 and positive 4. And then I have to, it's not optional, I have to go back and check and make sure neither of those were part of my least common denominator. Whoops, look at that, x minus 4, right? So if I look back at my least common denominator, x cannot be 4 or 2. And that was one of my two answers, right? I got 4, but I can't have 4. So I need to cross that one out. That one's an extraneous solution. On the test, I may even ask you to label the extraneous solutions, not just cross them out, but say specifically, this was an extraneous solution. This one, though, is perfectly fine. That's my answer. So is everybody feeling okay with section 4 that we did last week? Maybe we're getting there, because we're going to get more practice today. Today is going to be the exact same thing, but with a couple extra steps at the beginning to get us set up. So everyone's full attention, phones away, earbuds out. Again, that should be a given when you first come in, but let's make sure that I've got everybody's full attention here, because what we're going to do today is word problems. Good news, though, you're only getting two kinds of word problems. Every single word problem that I will give you is going to be one of these two types. So as long as you figure out the two types, it'll work out real well. It'll be real easy to set it up. Then you'll solve it like normal. Now, real quick, show of hands. How many of you are in chemistry? Any of you in chemistry right now? Or any of you have taken chemistry? Okay. So do you guys remember solutions, diluting solutions, finding out specific, I'm forgetting what there's a specific term for it that they use in dilution, or no, there's another one too, titration. Use a couple of those where you're trying to get a specific concentration of a solution. You actually, if you remember that, you actually already have done this first type. It's very, very similar. We're going to call them rate problems. So here's the trick. Mary can wash all the windows of a retail store in 4 hours. Maxwell can wash all the windows of the same retail store in 6 hours. How long would it take Mary and Maxwell to wash all the windows of the retail store together? 10 hours, right? No, that doesn't make sense. We don't want we don't want it to take longer if they're helping each other out. It should be shorter. Does that make sense? So our guess is that it's going to be somewhere between maybe a little bit more than half of Mary's time, but a little bit more than half of Maxwell's time, somewhere in between there. So right now, without doing any work, my guess is my answer is going to be somewhere between 2 and 3 hours. Does that make sense? Is that a reasonable answer? Okay. So the way we set this up is we decide, okay, how much does each person do in 1 hour? How much does each person do in 1 hour? And that means making fractions. So Mary, in 1 hour, washes 1/4 of the windows, right? Because it takes her 4 hours to do the whole thing. So each hour, she does 1/4 of it. Maxwell, each hour does 1/6 of the windows. Does that idea make sense to everybody? That in 1 hour, we've got 1/4 of the windows washed and 1/6 of the windows washed. So what I want to know is, how much did they wash together? That's the problem I'm going to solve. Every single time here, with these types of problems where you have a rate, how quickly someone is doing something, you're going to do 1 over the first person, or 1 over the first rate, plus 1 over the second rate, equals 1 over the total combined rate. So let's try this now. This is exactly like solving what we did in section 4. I'm going to find the least common denominator. I'm going to multiply by the least common denominator. And if all goes well, I'm not going to have any fractions anymore. And I'm going to solve. So here, what's the least common denominator for 4, 6, and x? Not hearing any real confident answers. 12, right? 12 has 4 in it and 6 in it. And if you need to figure that out, you can do 4 is 2 and 2. 6 is 2 and 3. So it looks like I need 2 2s and a 3. But what am I missing? The x. Don't forget the x. So my least common denominator is 12x. I'm going to multiply both sides by that. So 12x on this side, 12x on this side. It's going to distribute in to each of my fractions, and I'm going to end up with 12x, 12x, 12x. And then I've got a whole bunch of reducing that happens. 4, let's use a different color. 4 goes into 12 3 times. So I've got 3x. 6 goes into 12 2 times. So plus 2x is equal to x and x reduce 12. So now 3 plus 2, just combine like terms, 3 plus 2 is 5x equals 12. Divide both sides by 5. X is equal to 12 fifths, which you could put in a calculator and say is about what, 2.4? Is that right? So fits in with our reasonable answer, right? Between 2 and 3 hours. If I had gotten 10 hours, I'd know I'd done something wrong because that's longer than either person does on their own. If I'd gotten less than 2 hours, I'd know I'd done something wrong because that would be faster than the fastest person working at twice the rate. And we know the other person didn't help out quite as much. Maxwell doesn't go quite as fast as Mary does. So always check and make sure that your answer makes sense. Let's try another one. Any of you read Huckleberry Finn? Do they still read that in school? A few of you? I forget, actually, it might not have been in that one. This problem's taking out of that, one of those 2 books. Suppose that Huck Finn can paint a fence in 5 hours. Tom Sawyer can paint the same fence in 9 hours. How long will it take Huck and Tom to paint the fence together? So again, we've got 2 rates, how fast one person does it on their own, how fast the other person does it on their own. We want to know how fast they do it together. So here we go. 1 over 5, first person's rate, plus 1 over 9, second person's rate, 1 over x, how quickly they can paint the fence together. Get that common denominator. This one, 5 and 9 don't have anything in common. So it's literally going to be 5 times 9 times x, 45x. So I'm going to multiply both by 45x. Well, actually both sides, which ends up multiplying in. Is everybody okay if I don't actually write out the big parentheses and say, okay, I'm multiplying both sides by 45x? Is everybody getting the idea that it gets distributed in, multiplied by every single fraction? So now, should all reduce real nice. 5 goes into 45, 9 times, so 9x. 9 goes into 45 5 times. X is reduced to 1. 9x plus 5x is 14x. And divide both sides by 14. X equals 45 over 14, or about, grab a calculator if you want to check. So for your answers, I am quite happy with 45 over 14. But if you want to make sure your answer makes sense, you might want to get a decimal. What do we get here? 3.2. And then we check to make sure that makes sense. Huckleberry Finn's painting time was 5 hours. Tom Sawyer's painting time was 9 hours. So half of 5 is 2.5. Half of 9 is 4.5. Our answer is in between those two. That makes sense. And so again, for those of you that haven't read the book, what is it? Huckleberry Finn is supposed to paint a fence, and Tom Sawyer walks by and he convinces him that painting the fence is so much fun that he should just pay him to do it. Pay him to do his chore for him. All right. Any questions with that type? Does that make sense to everybody? Let's try it then. Everybody go turn in the homework. Turn to number 1. Everybody try number 1 right now. Again, those of you watching this video later on, work with the people next to you, check your notes, get through number 1. So people work, so let's have more reviews. You could have, no, actually, that's perfect. That's 18. Yeah, that's perfect. That'll work out exactly. So all of the fractions should reduce. So the 6 goes into 18. Yes. Okay, so 3 is the greatest common factor. It's the biggest thing that goes into both of them. We want the smallest number that they both into. So your least common denominator is always going to be at least as big as your biggest number. So it's going to be 9 and a 2 also, because 9 and 2 make 18. 9 goes into 18, and so does 6. Does that make sense? You need both, because if you multiply by 8, these will reduce 3 over 6, but it's going to actually be 1 over 2. We'll still have a fraction. Does that make sense? We're doing okay over here? Yeah. Perfect. Yeah. All right, I'm seeing most of you are done at this point, so let's try it. First things first, let's set up our equation. So, Kiara, did you get your equation set up? 1 over 6. Oh, just a second. Let me get this going. There we go. 1 over 6 plus 1 over 9 equals 1 over x. That's perfect. Now, it says solve it. So I'm going to rewrite it. 1 over 6 plus 1 over 9 equals 1 over x. What is my least common denominator then? Jason, what was your least common denominator? 18x. There we go. 18x is going to be our least common denominator. We multiply that by the entire equation, by both sides. And again, it distributes in, get times 18x here, times 18x here, times 18x here. So how does that reduce then? AJ, what does that reduce to? Perfect. 3x plus 2x equals 18. Alani, what can we combine or simplify here? And what does that make? 5x equals 18. And Ishant, what's our last step? I'm getting used to everybody's new seats. There you are. Thank you. Divide by 5. So we get 18 over 5, which was about what, like 3.6? Somewhere in there, 3.6. And again, we check, does that make sense? It's a little bit more than half of 6, but less than half of 9. So we're set. Now, if this were a science class, I would make sure that you were putting in the units every time. I would still encourage you to put in the units, but I will not mark it off if those are missing. Unlike if we were teaching science, then yeah, you don't have those units, you're losing points. For here, your math is working right, you're solving correctly, it's good, but it certainly doesn't hurt to put the units in there. Yes. Go ahead, sign up and take the pass. So here we go. Let's look at the second page. Back to the notes. Everybody back to the notes. And let's look at our second type of word problem. Second type of word problem. Small group of students are having a study session one night. They decide to order pizza. The order amount is $24. Before the pizza arrives, another student joins the group. That person's not getting a free ride. So with the additional person, everybody's going to chip in. The average cost of the pizza, the amount that each person got to pay, goes down by $2. How many students were originally in the group? So this one, notice how it's different than the other one. This is a group that's being shared, or they're sharing some kind of task, some kind of amount. But then the price changes, the amount that they each have to contribute changes when the number changes. So either some people come or some people leave. So here, the way we set this up is we say, okay, what's the average cost to begin with? You really need to say what your X is going to be. So I'm going to say that my X value is the original number of students. The original number of students. So originally, they were going to do $24 divided by X students. Does that make sense? That was their original price. But now we've got how many more? Another student, one more student joins the group. So now the price is going to be $24 divided by X plus 1, one more student. But those don't actually equal each other, right? They're off by $2. Here's the trick. Where do I put the $2? Which one is paying more, the original price or the new price? The original one was going to pay more, right? So I have two options here. I can either subtract the 2 and say $2 less than that is the new price, or I could add it onto the other side and say the original one is equal to the new one plus the extra $2. It does not matter where you put that. I'm going to put it here. I'm going to say the original one decreased by $2 when we added the new student. Does that make sense to everybody? So the idea is original plus or minus the change equals the new one. Does that make sense to everybody? So let's solve this. I need to find a least common denominator. With these, it's typically going to be the bottom of this one, the denominator here, times the denominator here. Those are not actually going to be anything in common. Ali, that's fine, although you might want to watch this. So either way. So once I've decided my least common denominator is x times x plus 1, those two multiplied together, that's what I'm going to multiply both sides by. It gets distributed in x times x plus 1, x times x plus 1, x times x plus 1. Again, if everything goes right, if I pick the right one and set it all up right, all my fractions reduce, x's are gone, 24, it's 24 times x plus 1. The term that's not a fraction is not going to reduce. So I'm going to have a longer piece here, minus 2 times x plus 1, right? This piece, nothing reduces right there. Don't lose the negative. Is equal to the x minus or x plus 1's reduce, left with 24x. Now, the interesting thing with these problems is that most of the time you're actually going to get some more reducing here when we multiply this out. Bless you. So I'm going to do the distributive property 24, or actually, yeah, let's see here. Let's see how it goes. 24 times x, 24x, 24 times 1, 24. And then here, negative 2x times x, right? I can multiply the negative 2 times the x and just get negative 2x. I can distribute that in. Negative 2 times x is negative 2x squared. Negative 2x times 1, negative 2x equals 24x. I have x's and x squareds. Anytime I have x's and x squareds, I need to get all the terms on one side. Get it all equal to 0. So that means subtracting 24x from both sides. And this often happens. Notice how these two terms cancel out. 24x minus 24x is 0. So I'm left with 24 minus 2x squared minus 2x equals 0. Let's rearrange that. Negative 2x minus negative 2x squared minus 2x plus 24 equals 0. Anytime I have a number out in front of the x squared, if I can factor that out of everything, I should do it. It's going to make everything so much easier. Divide both sides, or divide the entire, actually, let's not talk about dividing, just factor it out. Take a negative 2 out, x squared minus x, plus x. Does everybody see that? We take the negative 2 out. First two terms become positive. 24 becomes negative. And then this should factor. Most of the time, it's going to factor real nice. Negative 2 times looks like x plus 4, x minus 3. So my answers are negative 4 and positive 3, right? What's wrong? So the negative 2 isn't going to be 0. It's just hanging out there. It's not going to affect my answer. I'll tell you right now, I have not made any mathematical mistakes. That's not what I'm getting at. What was I finding? Number of students. What's wrong with one of my two answers? You can't have negative students. Does that make sense? I mean, you may be asleep or tuned out, but you're still there. You're still a student. You're not negative. Does that make sense? So we can't get negative students. So check that. The negative doesn't work. The original number of students was 3. Then another student joined and we had 4. Does that make sense to everybody? Yeah, go ahead, Ali. So let's do one more. Yes. As soon as one of them comes back. Yes. So let's do one more here. A group of friends decides to rent a house in Aspen, Colorado. They're going to go for a week of skiing. The house costs $840 for the week to rent. Last minute, 3 friends decide not to go. They drop out on their friends. They bail, leaving the rest of them with the cost. Still got to get paid, right? Can't go if you're not going to pay for the house. So they all have to figure out, okay, how much do we each owe now? Everybody now has to pay an extra $14 to cover those 3 people that dropped out. So how many people did we start with? Let's try it here. Set it up. Original cost. Again, let's say that X is the original number. X is the original number of friends. Total cost divided by number of people. That's going to equal the new cost. So again, same total. The total doesn't change. The people renting the house out to them don't care how many people are there. It's $840 for the week. That doesn't change. But now we have X minus 3 friends. 3 friends are no longer going. Now, where do I put that $14? The easiest way to do this is to put it on this side. So if it's going up by 14, the original cost was less. Now everybody has to pay 14 more dollars. That equals the total amount that each person has to pay now. How are we doing with the setup for these problems? Do you see how it's the exact same as the last one as far as the type of problem? You guys, this is kind of nice. You only have 2 kinds of problems that we're going to give you. We have that rate problem, and we have this shared cost problem. I'm not going to spring anything else on you. It's just going to be these 2 types. So let's solve this now. 840 over X plus 14 equals 840 over X minus 3. My least common denominator is this denominator times this one. They're never going to have anything in common with these. They're always going to be 2 unique factors. So I'm setting this up. LCD is X times X minus 3. Multiply everything by that X times X minus 3. So here, X times X minus 3. Here, X times X minus 3. And here, X times X minus 3. Go through, reduce all the fractions. X's are gone. We've got X minus 3 times 840 plus, remember this one's not going to reduce, 14 times X minus 3. Here the X minus 3's reduce, 840X. Do the distributive property. $840 times X is 840X. 840 times negative 3. Here's where you might want to use a calculator just to be safe. 3 times 840. Negative 2,520. Plus 14x times x. 14x squared. 14x times negative 3. Gets me negative 196 equal to 840x. Subtract that 840x from both sides. And again, just like on the last one, that actually cancels out. I end up with 0. So I'm left with that was, oh, and it should be, you may have, this was, you're referring to the fact that it should have been an x. So the 196 was 14x times negative 3. Does that make sense? I just left off the x there. It is. I don't even know what I put in there. Thank you. So it was you. Who is the other? Okay, a couple people. All right. So I'll write that down. Thank you for fixing that, because that would have been a problem. Those of you in the future classes watching this. The 14x times negative 3 should be negative 42. I am still not sure what I did there. Let's fix that right now. So that should be, if I can get it, negative 42x. There we go. Sorry about that. Thank you again for catching it. Negative 42x. Now we subtracted that 840x. We're left with, let's rearrange it a little bit. 14x squared minus 42x minus 2520 equals 0. Now that looks really rough, but every time with these problems, if this is going to work out well, I'm going to be able to divide everything by 14. Let's factor that 14 out. I'm left with x squared minus 3x, and then that 2520 divided by 14 is 180. Does that make sense to everybody? Thank you. Right here in the middle. This should factor, right? Because we're supposed to end up with a nice whole number answer. So looking at this, 180 subtracting to 13, it's not 18 and 10. Let's try some other numbers. Maybe 9 would go in. We're just going to grab a calculator and start checking. 180 divided by 9 would be 20. That's worse. How about by 12? 180 divided by 12. 12 and 15, right? Just try it until you get one. So I did 2,520 divided by 14. Does that make sense? So this does factor into 15 and 12. So the 14 still on the outside, x minus 15, x plus 12. So that when I multiply it out, I get that negative 3x in the middle. My two answers then, the 14 is not going to be a part of my answer. It's just hanging out there, multiplying the whole thing by 14. My answer is x equals positive 15 or negative 12. Which of those doesn't make sense? The negative 12. Again, that one doesn't work. The 15 does. So there were 15 friends originally. What if they asked you how many friends are there at the end? How many friends actually go on the skiing trip? It's the 12. Notice how it ends up oftentimes being related to that extraneous solution that we got. Actually, this isn't really an extraneous solution. It's one that just doesn't make sense for people. But if you had solved it the other way, solved for the, with x being the final number of students and the initial being x plus 3, you would have gotten a positive 12 and a negative 15. Would have switched them. So, but here, that 15 is our answer. How are we feeling with this? Okay, we're getting there. Time for you guys to try it. The homework is only numbers 1 through 4. We've got not too many. We got about 5 minutes here for this class. Other classes might have a little bit more, but about 5 minutes. Knock out one more of those problems. Try number 2 or 3, maybe. Maybe try number 3 right now. Okay, and then if you finish that, try the other ones. If you finish all 3 of them real fast, feel free to work on other, like anything you've got left over from section 4 or before.